So hey everyone, welcome back to our channel. So this is the Codeforces playlist that we will be solving Codeforces problem. So this is the seventh video. So here we have already solved around 6 problems. So let's see a quick recap. So first one is watermelon problem with conditionals. So with the next problem we have seen strings and character indexing. So in the next problem we have seen multiple value inputs and loops. After that string comparison. And in the next problem we have solved ceiling divisions and long like that. So today we are solving Codeforces 50A, that is domino pilling. So this is a beautiful little math problem. So there is no loops, no arrays, no strings. So just a pure logical thinking and one clean formula. But don't let the simplicity fool you. The thinking process behind it is exactly the kind of reasoning that competitive programmers develop over time. So let's get into it. So first, let me open this problem. So domino pilling. So this Codeforces problem here, it is another classic A problem, that is the warm-up difficulty level. So the theme is dominoes. So you probably played with dominoes before, those rectangular tiles that are exactly twice as long as they are wide. So in this problem, we have a grid, an m by n board, and we want to place many 1 cross 2 dominoes on it as possible without overlapping. So each dominoes covering exactly 2 cells. So the question is, what is the maximum number of dominoes we can place? So it sounds simple. So and once you see the key inside, it is simple, but getting there requires thinking carefully. So let's read the full problem. So here you are given a rectangular board of m cross n squares, and you are also given an unlimited number of standard domino pieces with 2 cross 1 squares. So you are allowed to rotate the pieces. You are asked to place as many dominoes as possible on the board so as the meeting of the following each conditions. So each domino completely covers 2 squares. No two dominoes overlap. Each domino lies entirely inside the board, so it is allowed to touch the edges of the board. So find the maximum number of dominoes which can be placed under this restriction. So the next one is the input. So in a single line, you are given two integers m and n, the board size in the square. So it can be in the range of, these are the constraints from 1 to 16. So the next one is, that is output. So the output, we have to print one number. So the maximum number of dominoes which can be placed. So let us see the sample programs. So these two are the sample programs. So the sample one is input 2 and 4, that is 2 cross 4. So total of 8 cells. So each domino covers 2 cells. So 8 divided by 2 will be 4 dominoes. So after that 3 cross 3, that has 9 cells. So 9 divided by 2, it is 4.5. So but we can't place half domino. So we will floor it to the value, that is 4. So do you see the pattern forming? So let me ask you, what's the total number of cells of an m cross n board? So it is m cross n and each dominoes cover exactly 2 cells. So the maximum number of dominoes is m cross n divided by 2. That is rounded down. So that's it. So that's the entire problem. So let's make sure we understand why this is always achievable, why we can always actually place that many dominoes, and it is not just a theoretical upper bound. So first let's build the logic of it. So let's think about this more carefully, because in the competitive programming you need to not just find the answer but also convince yourself it is correct. So first, the upper bound argument. So every domino covers exactly 2 cells. A board has m cross n cells total. So we can place at most m cross n divided by 2 dominoes. So we simply don't have enough cells for more. So this is our upper bound. So can we actually always achieve this upper bound? So let's think about two cases. So first case is if m multiplied by n is even number. Okay. So I multiply m with n, and if I get the output as even number, So here the total number of cells is even. We can tile the entire board perfectly, no cells left uncovered. So think of it like scan a board row by row and placing dominoes horizontally side by side. So every cell gets covered. So we achieve the exact m cross n divided by 2 cells. So if this value is instead of even, so if it is odd, so when that this only happens with both m and n are odd. So the total cell is odd and one cell is always be left uncovered no matter how you place the dominoes. So the maximum number is, we can say m multiplied by n minus 1 and it is divided by 2. Okay, it is nothing but the floor division. The floor division of m multiplied by n. So in both cases, the answer is simply floor value of m multiplied by n, or in C++ in integer division m multiplied by n by 2. So here's the beauty. So C++ integer division already does the floor division. So for positive numbers, so we don't need to even check for the ceiling formula from the theater square. So the plain division gives us the exactly what we want. So there is no loops, no conditions, just one multiplication and one division. So let me double check with both samples. So first let me take 2 examples, 2 multiplied by 4, that is m cross n here, and divided by, so this time I will get the value 8 divided by 2, that is 4. So 4 is the output here. So next problem. So 3 multiplied by 3 divided by 2. So as you can see here, it is 9 divided by 2. So the floor division is simply it's 4, because 8 by 2, that is 4, 1 will be remains. So now do we need a long? So the maximum multiplied is 16 number. So if both are also 16, 16 cross 16 is 256. So it is divided by 2 also 128. So it never overflow the integer value. So plain int is perfectly fine here. So now let us see the visual representation of this problem before solving this multiplication and division. So here let me take a 3 cross 3 board. So this is the 3 cross 3 board. So we place domino horizontally covering row 1 and column 1 2. So the domino B vertically covering this column 3 and this row 1 and 2. So if we do that, one cell for row 3 and one cell for column 3 will be left uncovered. So that's the one unavoidable leftover when the total number is odd. So we place 4 dominoes. That is, the first one is first row, first 2 columns. So in this row, these 2 columns. So you will see a square shape here and you will see another square shape here. Like that, you can at most you can place around 4 squares. So first let us set up the environment. So I'm using C9 here. If you are familiar with anything, you can use that compiler. So I'm using C9 for my code. So let's create any new file. So I have already using a new file here. So you can name it as dominopiling.c++. So this is going to be one of the shortest solutions in our playlist so far, and that's one of the good things here. So now let us write the code. So first we want to get 2 inputs from the user. So as you can see, they have said m and n, that is the inputs. So int m and n. So after that, get the inputs m and n. So this scene will get the input from the user. We declare 2 integers and read them from the input on a single line. So the board dimensions. So nothing is new here. You have read pair of integers many times now in this playlist. So we use int because the values are at most 16. So nowhere near the overflow territory. So after that, there is a single line is our entire solution. That is cout. We are going to give the output of n multiplied by n divided by 2. And after that, I'll be going to next line. So I'm using backward slash n here. So this is a single line entire solution. So m cross n will multiply 2 dimensions to get the total number of cells on the board, and divide by 2 since both m and n and 2 are all of them are integers. So C++ performs integer division, which automatically flows the value. So for example, 9 by 2 will give 4, not 4.5. So this is exactly what we want here. So we wrap m and n multiplied in the parenthesis. So that is purely for readability to make it visually clear that the multiplication happens before the division. So in C++, multiplication and division have equal precedence, and it is also evaluated from left to right anyway. So the parenthesis doesn't change the result, but they may need to intend crystal clear. So that's why we have written like that. So we print the result directly inside cout without storing it in a variable. So for a formula, this is simple and this is perfectly clean. So no counter, no loop, no conditions, just a mathematical formula. So what if we overcomplicate it? So now I want to show you something important. So let me show you a solution that many beginners write when they first see this problem. So for example, instead of this, let me comment this line. So what most beginners would do here is, instead of doing that, first they'll declare m and n. So after that, they'll get the input m and n. So after getting, they will declare one more variable like this total, and they will multiply and store it. So after that, declare one more variable that initialize with 0. So then what they will do, if total modulus 2, that is if it is the total number is even, so that time, so if the total number is even, so then the answer is total divided by 2. So if not, that is else case, else, so the answer is, that is for division. So here that is total minus 1 divided by 2. After that, they will print it like cout like this. So as you can see, this is one of the biggest line they have written here, around 2, 4, 6, 8, around 10 lines for a program. So, but we just need 3 lines. Instead of 3 lines, they will be using 10 lines of code. This solution is also correct. It handles even and odd totally separately, but look at how much longer it is compared to this 3 line of code. So here's the lesson that both branches do the same thing. So whether total is even or odd, integer division, so it gives the correct answer in C++. So the if else is completely unnecessary. So when you find yourself writing if else where both branches produce the same formula, so that's a signal to simplify it. So in competitive programming, always ask, is there any single expression that covers all these cases? So the cleaner version is this multiplication. So I don't need this line. I can remove it and I will uncomment it. So now let us test the test cases here. So let me copy this and run this code. So here it is building. So 2 and 4 gives 4. So 2 and 4 gives 4 and 3 and 3 also gives 4. So let us rerun it. So 3 and 3 also gives 4. So as we can see that the solution is perfectly working. Let us test with some more test cases. For example, the maximum they can give is 16 and 16. So if it is 16 and 16, it is multiplied by both value, that it will give 128. So 256 and 256 divided by 2 will give 128. So the value is 128, and for m is 3 and n is 5. Let us give that. So 3 and 5. So the multiplication should be 15. So if you get, you should get the value, that is 7, because 15. So in that you are doing integer division, so that time you get the value 7. So let me copy this code and get back to the compiler and go to the submit tab. So once you go here, just paste the code. So make sure that the correct language you have chosen for the program you have written, and see the problem name as well. So you are choosing the correct problem for the same solution. So next, after this verification is success, just submit the solution. So it is running under test case and it is being accepted. So today's problem was short, but the recipe in C++ for positive integers, a divided by b in C++ automatically gives floor values, and it truncates the value decimal. So the next thing is, that is math first thinking always. So before writing a single line of code, so ask, is there direct formula for this problem like m cross n cells divided by 2 like that? So after that, simplify your conditions. When you write and if else and both branches produces the same formula, so collapse them into a one expression. So this is the sign of showing maturity as a programmer. So here's the today's challenge. So instead of 1 cross 2 dominoes, you had 1 cross 3 dominoes that covers exactly 3 cells. How many can you fit on a M cross N board? And a harder version, what if you had MX, you want to use as many 1 cross 2 dominoes as possible, but any cells left over should be covered by 1 cross 1 monominos. That means a single side. So how many of each do you need? So think through the math and post your formulas in the comments. So no code needed, just a formula and your reasoning. So and that's for this Codeforces 50A is proven, visualized and submitted. So this is the 7 problem. So 7 problems down. Today showed you that something's the most powerful solution is the shortest one. So a single line of math that elegantly handles every test case. So in the next video, we'll be seeing with another problem. So we keep climbing. Each problem adds something new to your toolkit. So if this playlist is helping you, please like the video, subscribe and share it with someone on their competitive programming journey. So it genuinely helps the channel to grow. So comment below what surprised you most today, and was it how simple the formula was or the more complicated version I showed? I'd love to hear your thoughts. So see you in the next one.